So after this row reduction, we can find the column reduction, right? For finding the optimal solution, we have to scan the rows and columns. And in the second column, again, the least value is 5. Now I will do the column scanning. In the first column, I have 1, 0. Hello my dear students, welcome back. I am Shweta, Computer Science faculty, Vidhyaashram First Grade College, MYSURU. In my last session, I have discussed about assignment problem using Hungarian method, balanced problem and unbalanced problem also. So today I will discuss some other important problems on Hungarian method. So first problem, it is minimization problem. So here you have number of jobs and machines. What is the first step in Hungarian method? First, you have to check whether it is a square matrix or not. So, how to check the square matrix? So, number of columns, it should be equal to number of rows. So, here I have 4 columns and I have 4 rows. So, 4 equals 4. It is a square matrix. If it is square matrix, you can proceed further. So, next step is row reduction. So, after finding the square matrix, we have to find the row reduction. So, how will you find the row reduction? So, just consider all the rows. In every rows, you have to consider the least value and subtract with other values. So, here in the first row, the least value is 2. And subtract this least value with the other values. So, 2 minus 2 is 0. And 10 minus 2, 8. 9 minus 2, 7, and 7 minus 2, 5. And next we have the least value in second row is 4. So 15 minus 4, 11, 4 minus 4, 0, and 14 minus 4 is 10, 8 minus 4 is 4. And in the third row, the least value is 11. So 13 minus 11 is 2, and 14 minus 11, 3. 16 minus 11 is 5, 11 minus 11 is 0. And in the last row, the least value is 4. So 4 minus 4, 0, 15 minus 4, 11 and 13 minus 4, it is 9. 9 minus 4 is 5. This is your row reduction. So after this row reduction, we can find the column reduction, right? So now I will show you the column reduction. So just consider the first column. In first column, the least value is 0. So 0 minus 0 is 0 and 11 minus 0, 11. 2 minus 0, 0 minus 0. And in the second column, the least value is 0. So you will get the same value 8, 0, 3 and 11. In the third column, the least value is 5. So 7 minus 5 is 2. 10 minus 5, 5 minus 5 is 0 and 9 minus 5 is 4. In the last column, the least value is 0. You will get the same value 5, 4, 0 and 5. So now this is your column reduction matrix values. So now what you have to do is you have to find the optimal solution. Once you got the column reduction values, so easily you can find the row scanning and column scanning. For finding the optimal solution, we have to scan the rows and columns. So here I will find the row scanning now. In first row, we have 1 0. If you get 2 zeros, you have to skip that row. So in first row, I have 1 0, put a square box around that 0 and put a vertical line. And in the second row, you have 1 0. If you get 2 0, just skip that line. Put a square box around that 0 and put a vertical line. In the third row, we have 2 zeros. You can skip these zeros. And in the fourth row, 1 0 also cancelled. There is no other 0. So now row scanning has completed. Now column scanning. So first column is cancelled, second column also cancelled. In the third column, we have 1 0. Put a square box around that 0 and put a horizontal line. In fourth column, we don't have any other zeros, so you can skip this column, right? Now you can observe this matrix values. How many number of square marked is there. So 1, 2, 3. 3 square marked is there. So number of square marked is equal to 3. Number of square marked is equal to number of rows. So number of square marked is 3, but the number of rows is 4. So it is not equal, is not a square matrix. So you can move further. After this row scanning and column scanning, if you not get the square matrix, you can move further. So here you just observe the deleted cell values and undeleted cell values. So these are the deleted cell values and these are the undeleted cell values. So out of this undeleted cell values, you just pick one least value out of this. So here the least value is 2. Out of this undeleted cell values, the least value is 2. Subtract with other values. So 2 minus 2 is 0. 5 minus 2, 5 minus 2, 4 minus 2 and 4 minus 2, 5 minus 2. And the remaining values are same for deleted cells except this common value for both vertical and horizontal lines. So here 3 is a common for both vertical and horizontal line and 2 is also a common for both vertical and horizontal line. You just add that number with least value. So 3 plus 2 is 5 and 2 plus 2 is 4 and the remaining values are same. So it is 0, 8, 11, 0 and 0 and 11. So now I will use diagonal selection. So after this row scanning and column scanning, you can go for diagonal selection. So here I will choose a diagonal selection. In first row, I have 2 zeros. You can choose any other 0. So I will choose this first 0 and you can cancel this second 0. And in the second row, you have 1 0. That is second row, second value is 0. And in the third row, we have 2 zeros. I will choose this diagonal selection. So first I have marked this 0 and I have cancelled this. And in the diagonal selection, I have marked this second 0. And in diagonal selection, I have marked this third 0. And I can cancel this 0. In the fourth row, when it comes to the fourth row, I have only 1 0. But in the column, if you consider this first column, already have marked 1 zeros in a first column, first value. But you can't choose this again. You can't assign this 0 again because over that I have 1 more 0 assigning. So I can't choose this. So now again I got the 3 square marked. So now I will choose another alternatives. So this is the first alternatives and second alternatives. So now I can't pick the zeros properly. So I will choose another values. So here 0, 8, 0, 3 in first row, 11, 0, 3, 2, 4, 5, 0, 0 and 0, 11, 2, 3. In the first alternatives, I have choose this first 0 and in the second alternatives, I will choose this 0 and I can cancel this 0. And in the second row, again, I can select this diagonal section. And in the third row, I have 2 zeros. So already have select 1 0 on this column. So I will select the next 0. I can cancel this 0. And remaining in the last row, I have only 1 0. This is I have marked. So now you can cross verify whether it is a square matrix or not. So number of square marked is equal to number of rows. So how many zeros I have marked here? 1, 2, 3, 4. So 4 is equal to number of rows also 4. It is a square matrix. Now you can find the assignment and total cost. So now I will find the assignment. So optimal assignment is so here first row and third column. This is A, B, C and D. This is second row, third row and fourth row. So first row is connected to C and second row to B, and for third row 3 to D, and for fourth row it is D. So 1 to C, 2 to B, 3 to D and 4 to D. So now you can find the total cost. So 1 to C. So what is the value, original value of 1 to C? That is 9. 9 plus next value is 2 to B, job J2 to machine M2, it is 4, and 3 to D. 3 to D means J3 to M4, it is 11, and fourth one is 4 to 1. 4 to 1 means it is 4. So the total cost is 28 rupees. So this is your total cost for this problem. So easily you can find the optimal assignment and you can find the optimal solution for this problem. So this is your assignment problem for different cases. So you can go for 2 alternatives. If you get some possibilities, you can go for 2 alternatives. And the next problem. So here you have jobs. You just observe this whether it is a square matrix or not. Here I have 4 columns but I have only 3 rows. So is this balanced? No, it is not a balanced problem. If it is not a balanced problem means you can add dummy row or dummy column according to the requirement, right? So now it is not a balanced problem. In columns I have 4 columns but only I have 3 rows. So now I will make it as balanced by adding dummy row. So J4 I am adding with 0 matrix. So row value is lesser than the column value. So I am adding 1 dummy row. So now you can observe this. Now it is a balanced problem. So now you can proceed. So row reduction. So in the first row the least value is 15. So 15 minus 15 is 0. 21 minus 15, 6. 25 minus 15 is 10. And 29 minus 15 is 14. And in the second row, the least value is 5. So 5 minus 5 is 0. And 10 minus 5. And the third value is 14 minus 5 is 9. And the last value 16 minus 5 is, it is 11. In the third row, the least value is 7. 7 minus 7 is 0. 12 minus 7 is 5. And 16 minus 7 is, and the last value is 19 minus 7, it is 12. And in the last row 0, 0, 0, 0 is there, so it is 0 only. And the next is column reduction. After getting this row reduction, you can find the column reduction. So in the first column, all the values are 0. If it is 0 means all the values are 0. In the second column, least value is 0. Again, you will get the same value. 6, 5, 5 and 0. In third column also, 0 is the least value. It is 10, 9, 9, 0. In the fourth column, least value is again 0. So this is your column reduction. So after this column reduction, you can find the optimal solution. By using the column value, I will find the optimal solution. So first I will find out row scanning. In first row, I have only 1 0. If you get only 1 0, you can put a square box around that 0 and put a vertical line. In second row, there is no zeros. You just skip that. In third row also, no 0. In fourth row, I have 3 zeros. If you get 2 more zeros, you just skip that line. And now you can go for column scanning. So in the first column, it's deleted. And in second column, I have only 1 0 and put a square box around that 0 and put a horizontal line. And in third column, there is no 0 and fourth column also no 0. You just put a horizontal line. So now row scanning and column scanning has completed. So what is the next step? Now you can observe the deleted cell values. So have covered the zeros with minimum number of vertical lines and horizontal lines. But still we didn't get the square matrix because the number of square marked is equal to 2 but the number of rows are 4. So 2 is not equal to 4. Now you can proceed further. So now this is your deleted cells and these are the undeleted cells, right? Pick a least value here. Least value is 5. Subtract with the other values 6 minus 5, 10 minus 5, 14 minus 5 and 5 minus 5, 9 minus 5, 11 minus 5, 5 minus 5, 0, 9 minus 5 and 12 minus 5, 7. And the remaining values are same except this common value for both vertical and horizontal line. So this is common value for both horizontal and vertical line. You just add this least value to this number. So it will become 5. And the remaining values are same. Now you can go for diagonal selection. So in the first row, I have only 1 0. I will put a square box around that 0. In second row, I have 2 zeros. This 0 I can't assign because over that I have assigned 1 0 already. So you can't assign this. You can cancel this 0 and you can put a square box around that 0. In third row, we have 2 zeros but already over that I have assigned 1 0. So you can't assign this. And over that we have one more 0. So you can't assign this 0. So we can't assign this 0. Here also you can't assign this 0. And now I can assign this 0. Because over that I don't have any other 0. So if you are assigning this 0, you can cancel this 0. So now you can cross verify whether it is a square matrix or not. So I have assigned 1, 2, 3 zeros. So number of square marked is equal to number of rows. So how many zeros I have assigned? 3 zeros and number of rows is 4. So is it equal? No, it is not equal. So it is not a square matrix. Again you can move further. So now these are the deleted cell values and these are the undeleted cell values. So out of this undeleted, pick a least value. Least value is 4. Subtract with other value. So now least value is 4. 5 minus 4 is 1. 9 minus 4, 5. 4 minus 4 is 0. 6 minus 4, 2. 4 minus 4, 0. 7 minus 4 is 3. And these are the same values, undeleted cell values. So here I can cancel this line also because I am covering with an horizontal line. So now all the undeleted values are the same values except this common value for both horizontal and vertical lines, that is 5 and 0. So here you can add 4. 5 plus 4 is 9 and 0 plus 4 is 4. So 9 and 4 and the remaining values are same. So in first row I have only 1 0. I will assign this 0. And again you can't assign this. And in the second row I have 2 zeros. I will assign this 0. You can't assign this again. And again you can't assign this column 0 also. And now I will assign this 0. And finally I will assign this 0. And I will cancel this 0. So now you can cross verify the number of square marked. It is 4. The total number of rows also 4. So it is a square matrix. So now optimal assignment is so here J1, it is J1, J2, J3, J4 and 1, 2, 3, 4. So J1 to 1 and J2 to 2, J3, 3, J4 to 4th position. And now you can find the transportation cost. So what is the original value of this 1, 2, 3, 4? So J1 to 1. So J1 to 1 means it is 15. And J2 to 2, it is 10 plus 10. And J3 to 3, it is 16. J4 to 4 is 0. So 16 plus 0. So what is the total cost? So 15 plus 10 plus 16, it is 41. So this is your total cost. And the last problem in Hungarian method. So this is your last problem in Hungarian method. Please practice all the problems. 3 jobs are to be done by 4 machines. Each job can be assigned to one and only one machine. The cost of each job on each machine is given in the table. So here, you just observe this table. This is your given table. We have jobs and machines. So columns are only 3, but rows are, we have 4. So is it balanced? No, it is not a balanced problem. So now I will add one more column with 0 matrix. So I will make it as balanced. So now it is a balanced problem because number of rows is equal to the number of columns. So 4 equal to 4. Now it is a square matrix. You can proceed. So first I will find out the row reduction. In first row, the least value is 0. Second row also 0. Third row also 0. Fourth row also 0. So all the values are same. That is 8, 6, 4, 0, 6, 5, 5, 0 and 9, 10, 11, 0 and 7, 6, 8, 0. 7, 6, 8, 0. And now I will find the column reduction. In first column, the least value is 6. 8 minus 6. 6 minus 6 is 0. And 3, 1. And in the second column, again, the least value is 5. 1, 0, 5, 1. And third column, the least value is 4. 0, 1, 7, 4. And in the last column, least value is 0. So this is your column reduction. So now I will find out the row scanning and column scanning. So first I will do the row scanning. In first row I have 2 zeros. I will skip that row. And in the second row I have 3 zeros. Again I will skip that row. And in the third row I have 1 zero. I have put a square box around that 0 and I will put a vertical line. And in the last row you don't have any other 0. 1 0 also cancelled. So row scanning has completed. Now I will do the column scanning. In the first column I have 1 0. Put a square box around that 0 and horizontal line. And in the second column no zeros are there. In third column I have 1 zeros and put a horizontal line. So now column scanning also finished. So now you can find out whether it is a square matrix or not. So number of square marked is equal to number of rows. So square marked is 3, number of rows is 4. So it is not a square matrix. 3 is not equal to 4. If it is not a square matrix means you can find the least value out of this undeleted cells. These are the undeleted cells and these are the deleted cells. So out of these undeleted cells, 1 is the least value. So subtract with other value. 3 minus 1 is 2. 5 minus 1. 7 minus 1. 1 minus 1. 1 minus 1. 4 minus 1 is 3. And the remaining values are 2, 1, 0. And these are the common value for both horizontal and vertical line. So it is 0 plus 1 is 1. 0 plus 1 is 1. and the remaining values are same, 0, 0, 1. So now you can go for diagonal selection. So in first row, I have only one 0. I'll put a square box around that 0. And now you can choose this second row. So I have marked this 0 and you can cancel this 0. And in the third row, I have one 0. I will mark this 0. In fourth row, I have 3 zeros. So you can't select this 0 because already I have assigned. And again, you can't select this 0 because already I have assigned in that place. And you can assign this 0. Now you can cross verify whether it is a square matrix or not. So 1, 2, 3, 4. So number of square marked is equal to number of rows. So 4 is equal to 4. So it is a square matrix. So now optimal assignment is So optimal assignment is J1 to M3, J2, M2, J3, M4 and J4, M1. So now you can find the total cost. Total cost is equal to M3. J1, M3 original value is 4 plus J2, M2 5, J3, M4 it is 0 and J4, M1 it is 7. So 4 plus 5 is 9, 9 plus 7 is 16. So 16 is your final cost. So this is about your assignment problem using Hungarian method. I have explained all the steps in Hungarian method. Please practice all the problems. Easily you can score in Hungarian method. In my next session, I will come with a new concept called traveling salesman problem. So it is very interesting concept. So next we will discuss traveling salesman problem. Thank you.